Welcome back, chemistry people. Who's ready for some more practice? Yes, me too. First practice problem, and second one at the same time. Sample of elemental silver, Ag, has a mass of 21.46 grams. Question number one. How many moles of silver are in the sample? Well, for your visual reference, I have piled up here 1 mole of silver atoms. Now, again, this is not to scale, but just recognize or imagine that there is 6.022 times 10 to the 23 atoms of silver here, or 108 grams, just as sort of a visual reference as we walk through this problem. Before we do any math whatsoever, just compare this 1 mole, or this 108 grams of silver, to the amount that we're given in the problem, 21.46 grams. 21.46 smaller than 108 grams. Therefore, we're going to have less than 1 mole. So let's see if that's the case. We're going to bust out some dimensional analysis here. Again, we're going to start with our known amount, 21.46 grams of silver. We're going to convert to moles of silver using the molar mass. I'm going to use the one on the periodic table, which is going to be close to 108. 107.9 grams. And then when we solve, our units of grams cancel, and we're left with moles to get 0.1989 moles of silver. And that makes sense. If I were to cut this mole of silver in half, or roughly in half, I would go from about 108 grams to about 54 grams. So I have less than even a half a mole, which I do, so that makes sense. If I were to cut that 54 grams into half again, so at a quarter of a mole, I would have 27 grams, which again, I have less than that, so I should have less than a quarter of a mole. And again, when you're doing this on the test and you have to do multiple choice estimation, I would estimate 20 grams and maybe do 1 out of 100. The answer choices on the multiple choice are going to be far enough apart that you can do some pretty decent estimation and still figure out what the answer is going to be. So you should recognize here this is going to be about a fifth of a mole of silver. Okay, on to part 2. As we take a look at part 2, we're asked to figure out how many atoms of silver we have. Well, we know we've got 0.1989 moles of silver. From problem 1, to convert to atoms, we need to simply use Avogadro's number times 10 to the 23 atoms silver. This time our moles are going to cancel out. When we multiply this across, we get 1.198 times 10 to the 23 atoms of silver. Estimation skills will be huge, and you're encouraged to just, use 6 for Avogadro's number. Of course, be careful with those exponents, making sure that you've got the same magnitude when you're doing those estimations. On to problem number 3. Ooh, now we have calcium. This problem asks us what is the mass in grams of 7.81 times 10 to 22 atoms of calcium. Again, when you work through these problems, it's always a good idea before you start to go back and reference the amount in 1 mole. So again, I've got a little bit of a visual over here for you to help you sort of recognize what's going on with this problem. It's a little tricky here because numbers in scientific notation can cause problems. I'm going to just change this to 0.781 times 10 to the 23. And the reason why I'm going to do that is because I'm going to compare it to 6 times 10 to the 23. So if we do some estimation here, again, this is going to be super rough to start, just to give us an idea if we're on the right track. But if I use 1, this is kind of close to 1 times 10 to the 23, kind of, we'd be at about a sixth of a mole. And again, just sort of a rough idea, just tells me, okay, well, I definitely have less than half a mole. And I definitely have less than I mean, it's even less than a 6, so I definitely have less than a quarter of a mole. And that's just what I'm going to use to sort of get my mind around this problem before we even begin, that I'm definitely looking at something that's less than a quarter of a mole. And if you are a better mathematician than I am, I'm sure you can estimate a little bit. Oh, we could use 0.8, right? Yeah, 0.6 would be a tenth, and 0.8 would be a little bit more than a tenth. I suck at math. But just use a number that's easy for you. If it's a little bit of a giant estimation, that's fine. But do some estimation. That skill is going to come in super helpful on the multiple choice section where you don't get to use a calculator. Okay, time to tackle this problem. As we take a look here, how would we solve this using the calculator? We're going to start with the amount that we're given in the problem. 7.81 times 10 to the 23 atoms of calcium. We can't go directly to grams. We have to go first to moles. So atoms to moles. In fact, if you don't know what to do, always go to moles. So 1 mole is going to be Avogadro number 6.02 times 10 to the 23. And from there, we can convert from moles to grams of calcium. 1 mole is going to be 40.08 grams of calcium. Again, I'm pulling this from the periodic table. Calcium, boom, 40.08. And then it's just bust out your calculator and solve. Notice all of our units except grams of calcium will cancel out, and we'll be left with 5.20 grams of calcium. And again, as you're estimating, we knew we would have less than a quarter, and we did some seriously rough estimation there. And 5 is definitely less than a quarter of a mole of calcium, which is 40 grams. And we expected less than a quarter. This is roughly a little more than a tenth of a mole, which seems pretty close. I mean, if we had 0.6, if we used 0.6 would be a 0.6 times 10 to 23 would be a tenth. So this is a pretty good, I feel pretty good about this. Plus I get the teacher's edition, so that's correct. Plus I'm a genius. Next problem. Next problems. Okay, here we go. Talking about Freon 12. Freon 12, which has the formula CCl2F2, is used as a refrigerant in air conditioners and as a propellant in aerosol cans. Space. Given a 5.56 milligram, watch out, sample of Freon 12, question 4 asks us to calculate the number of molecules of Freon 12 in the sample, while question number 5 asks us how many atoms of chlorine are in the sample. So let's tackle number 4 first. As we take a look there, we're going to start with our original 5.56 milligram sample. So 5.56 milligrams of CCl2F2. We're going to convert this first from milligrams to grams. So be careful, watch out, especially those mass values. You'll often be given things that are not in grams. You need to convert to grams first. So 1 gram is 1,000 milligrams. From there, we're going to go from grams to moles. 1 mole of CCl2F2 is equal to 120.91 grams. And if you're wondering, where do we get that 120.91 grams from? We went to the periodic table. We just took 1 carbon, 2 chlorines, and 2 fluorines and added those masses together to get the 120.91 grams. From there, we can convert to molecules. So moles, CCl2F2 to molecules, CCl2F2. 1 mole is going to be 6.02 times 10 to the 23 molecules. So if we bust out our calculator, we should notice that all of our units will cancel out except for molecules of CCl2F2. And when we put that in a calculator, we get 2.77 times 10 to the 19 molecules of CCl2F2. Again, as you try to estimate this and try and think about whether or not this answer makes sense, in 1 mole we have 120.91 grams. And in 1 mole we would have Avogadro's number of molecules. Well, we've got a lot less than 1 mole because we have only 0.00556 grams of CCl2F2, which is a lot less than 120.91 grams. So this answer, which is a lot less than Avogadro's number, only 10 to the 19, makes sense. Genius. Okay, question 5. This one's going to be set up the exact same way as question number 4. We're going to start with 5.56 milligrams of CCl2F2. And, you wouldn't have to do this if... I'm just going to write it out here. I know you math geniuses. 5.56 milligrams. Again, we need to convert from milligrams to grams. From grams, we'll go to moles. Again, this 120.91 coming from the periodic table, CCl2F2. I'm going to label here so I can make this a little more clear. CCl2F2. And here's where we're going to change. We're going to go from moles of CCl2F2 to moles of CCl2, no, just kidding, to moles of Cl. And so as you look at your equation for CCl2F2, for every one of these, there are 2 Cl's. Again, that just comes from the formula that's given to us in the problem. And then from there, we can now go from moles to atoms of Cl using Avogadro's number. Let me shrink this down. Which equals 5.54 times 10 to the 19 atoms of Cl. Now, let's compare 5.54 and 2.77. 5.54 is twice as big as 2.77. And also, 5.54 times 10 to the 19 is twice as big as 2.77 times 10 to the 19, which makes sense because for every one of these, you have 2 Cl's. Boom.